The second parameter that all the models agree with is related to rainfall or precipitation. All the models actually predict we'll have an increase in the total rainfall around the planet, and it's interesting that the amount of the increased rainfall is related to how much global warming the models predict. We can see on the plot here on the right, the red dots represent different models from different groups around the world, and the increase in rainfall shown on the y-axis in percentage increases depending on the increase in temperature that these models predict. So models which predict that the climate is going to warm by 5 degrees due to double CO2 have maybe a 15% increase in rainfall. Models which predict only a 2-degree global warming will have maybe only a 3 or 4% increase in rainfall. But they all show an increase in rainfall basically because we're increasing the amount of water vapor in the atmosphere because of more evaporation from the oceans, and we know also warmer air can hold more water vapor, and then eventually this has to fall out and we have an increased rainfall. But we need to remember that increased rainfall doesn't necessarily mean we have more water at the surface to use for drinking, for agriculture, because we need to look at always the difference between the water coming to the surface and the water leaving the surface due to evaporation. And if global warming increases the temperature, we also increase the evaporation from lakes, from rivers, from vegetation. And it turns out in the models, the evaporation is much more than the increase in the rainfall. And so overall, we actually have a drying out of the surface, even though rainfall itself globally will likely increase in a warmer climate. But more important, when we look at the rainfall patterns in the model going into the future, and here we have simulations of a 1 degree global, 1.5 degree global warming, 2 degree, 3 degree, 4 degree warming, we see an intensification of the hydrological cycle. Unlike the temperature where everywhere it gets warmer, when we're talking about precipitation, some parts of the planet shown in green here will have a lot more rainfall, and areas in the brown and the orange we're going to have a decrease in rainfall. And it's also not randomly distributed. This is related to the circulation patterns in the atmosphere that we've spoken about during the course, that in the tropical regions where we have a lot of rainfall, we're going to see an increase in rainfall there, as well as in the temperate zones in the northern parts of the US, Canada, Europe, Asia. We'll expect to see more rainfall in the future. But in the subtropical regions, like in the Mediterranean and in California and in southern Africa, in Australia, we can expect to see a decrease in rainfall with much more higher frequencies in drought events and maybe even heat waves. It may be difficult to see on these plots, but there are certain areas where we have little lines, diagonal lines, and areas where we don't have the lines. The areas where we don't have the lines is where 90% of the models used in the IPCC report agree with each other and where we have a lot more confidence in the results. If you have these hashed lines, it means that some models disagree, some show an increase, some show a decrease, so we maybe have less confidence. But in many of the areas, especially in the Mediterranean, where the models predicted drying, all the models agree that this is what we're going to see in the future. And it looks like we're already seeing it in places like Spain, Portugal, Italy, Greece, and also in Israel. We see dramatic decreases in rainfall in the last decades, and this is predicted to increase in the future. So if we look at some statistics based on these changes in the frequency of these rainfall events, both the wet events, the heavy rainfall, and the dry events, we can see here some statistics again from the IPCC report, looking at heavy events which would occur once on the planet, on the whole planet, once every 10 years. So looking from 1850 to 1900s, if these occurred, say, once every 10 years, every decade, if we look at what happens when you warm the planet like we have today to, say, 1 degree global warming, then we increase the frequency by about 1.3 times out of every decade. And at the bottom, the bars also show the intensity of these heavy precipitation events. So these events are 6.7% wetter. There's more moisture in the atmosphere, bringing a lot more rainfall when we do have these intense events. And when we go to the future climate of a 1.5 degree, 2, and up to a 4 degree global warming, we can see the frequency of these very intense rainfall events, the flooding events, will occur maybe 2.7 times out of every decade, and the intensity of these events will increase by up to 30% more rainfall in these events. So both the frequency of these very intense rainfall events and the intensity of them, the magnitude of them, is predicted to increase as the temperatures get warmer and warmer in the future. And if we look at the other side of the spectrum, the areas where things are going to get drier and we're going to have drought conditions, impacts on, obviously direct impacts on agricultural yields and various ecosystems, we can see again, let's take the models, take all the models, and we see what's the most intense drought which occurs once every decade in the period from 1850 to 1900s. That has increased already from a 1 degree global warming to 1.7 times every decade. And also the intensity of these dry events has started to increase. And again, if we go to a global warming of 1.5, 2 degrees and 4 degrees, by the time the planet is warmed up by 4 degrees, we're going to have these very intense drought, dry events at a rate of 4.1 times every decade. And again, an increase of the intensity of these events, which is described here as a function of the standard deviation of the data.